Good morning students, myself Dr. K.M. Dadure, Assistant Professor, Bajaj College of Science, Wardha. Today I am going to discuss in this section a liquid SO2 as a solvent. Okay, so student, as far as the liquid ammonia as a solvent we had discussed in our previous section or in our previous presentations very well. So here also we will discuss the liquid SO2 as a solvent in with some exceptional characteristics properties. So let's see what is the liquid SO2 as a solvent. So before we going to discuss a liquid SO2 as a solvent, we actually try to introduce its some important nature, and as far as its importance parameter is concerned, it is a non-protonic solvent. Okay, student, as far as the SO2 group is concerned, there is no proton, so overall we can say that it is the non-protonic solvent and which contain no hydrogen atom, and therefore this is the reason it doesn't produce a proton during the any productivity. Okay, it doesn't produce any proton during the any productivity okay, and we can say during the ionizations. Okay, so though SO2 is a gas under the ordinary condition, it is readily liquefied and used very extensively for the chemical reactions. Okay, this is the another fact about this liquid SO2. So with this, its physical property is melting point is around 196.5, boiling point is 263 Kelvin, and its dipole moment is 1.61 dB. Okay, so there are some important characteristics properties of the liquid SO2 as a solvent, and these are, in that first is the liquid range is very high, and due to this liquid range it can work as a good solvent. So next is high dipole moment, and because of this high dipole moment property, so it dissolves the many inorganic compounds in it, and therefore it behaves as a moderately the good conductor for the many alkali metals, ammonium and tetraalkyl ammonium chloride, bromides, iodides and thiocyanates are the poor conductors. It is found that the conductivity of the electrolyte solution in the liquid SO2 is basically the increases with the size of the cations. Okay, so next important one, it acts as an electron acceptor, and it acts as an electron acceptor, it means that, and it forms they form the molecular complexes. Okay, and this is because of due to the presence of the vacant bonding orbitals on sulfur atom. Okay, sulfur atom is a contain the vacant bonding orbital, and that is the reason it forms a molecular complexes. Okay, the next one, solubility. Okay, as far as the solubility is concerned, in the ammonia sections we already discussed solubility in case of the organic or solubility in case of the inorganic compounds. So here also we will discuss the solubility in case of the inorganic compounds, and in that we will see the iodide are found to be the most soluble in liquid SO2. In case of alkali metals, halides, there are number of different solubilities factor associated with their orders. So alkali metals, sulfates, sulfides, acetates, cyanides, thiocyanates, they are also found to be soluble. Okay, metal sulfates, sulfides, oxides, hydroxides, they basically soluble but not completely soluble, and that is the reason they called as sparingly soluble. Okay, so this is all about solubility related to the liquid SO2. Okay, and all these are the examples. These are the interhalogen examples, and POCl3s, some halides in that, carbon tetrachlorides, okay, silicon tetrachlorides, this is a SnCl4, this is steam chloride. Okay, so next one, in the organic compounds, how the solubility is associated with organic compounds. So basically SO2 is found to be a better medium for the dissolving of covalent compounds. Okay, in that aromatic hydrocarbons, alkenes, they are comparatively the more soluble than aliphatic hydrocarbons. So SO2 has also been used as a solvent for carrying a number of organic reactions. Okay, so this is actually the specialty of this SO2 as a solvent in organic compounds. Next, so let's see the reactions in the SO2. And as far as the reaction in the SO2 is concerned, so in the ammonia also we also discussed the same terminology, that is acid base reaction. So here we are just comparing the same reaction with the SO2. So let's see acid base reaction. So here in this case, acid base reaction, we can see there are number of various chemical reaction in the liquid SO2. So liquid SO2, they undergo autoionizations, and in that autoionizations we can see this is the reaction. Okay, this is an acid 1, this is the base 2, SO2 get combined together, and SO2 and base 1 is the reaction which is going to form. So this already we have discussed in the ammonia section, this reaction, but again as a liquid SO2 as a solvent, we are discussing here it again. So the next is redox reaction, and we know that what is the redox. Redox is the word itself is indicating that the reaction where the reduction and oxidation is simultaneously going on. So in this section we can see there are number of reactions, okay, of the gaseous sulfur dioxides are known, where it behave both as oxidizing and reducing agents. Okay, and in that we see the SO2 in the liquid state does not have any marked reducing or oxidizing tendency, and that is the reason it acts as a medium for the many redox reactions. Okay, it acts as a medium for many redox reactions. So let's see the examples. So this is an example where we can see, students, the simple reactions where the 6 moles of the Ki is reacts with the 3 moles of the SbSl5. Okay, and the reaction is taking place in presence of this SO2 as a liquid, and 3I2 plus SbCl3 plus 2Ki3 SbCl6 is the product. Okay, so this is actually the reaction where we can see that the iodine is liberated from Ki in the presence of SbCl5. Okay, so this is the redox reactions. Now next is the precipitation reactions, and student already the precipitations and meta-critical reactions we already discussed, but again we are repeating here in the liquid SO2 as a solvent. So those reactions in which the two soluble reactants react to give sparingly soluble substance and they precipitate it out are known as precipitation or metathetical reactions. So in this we will see how this metathetical reaction is taking place in this reaction, okay, in this chemical reaction where the SbCl3 plus 3 moles of the lithium iodide is react in the presence of this SO2, and you will see here the SbI3 as a get precipitated out, okay, with 3 moles of LiCl as a residue. Okay, with these 3 moles of Si, 3 moles of LiCl as a residue. And this is simple precipitation reaction where the SbI3 is get precipitated out during the reaction with SbCl3 plus 3 Li. And next is complex formation reactions. So again, in the complex formation reactions, a large number of the complex ions formation in the liquid SO2, and they are basically reported in a different ways. So basically sulfur dioxide itself does not take part in the complexation but provides medium for the purpose. It is a very important point. Sulfur dioxide itself does not take part in complexation, but it provides just a medium for the reaction to goes out for the complexations. And in that, one of the example is the solubility of the iodine in the liquid SO2. Okay, and this solubility of the iodine in the liquid SO2 is basically gently increases by the just additions of the potassium or rubidium iodide. Okay, and this is due to the formation of the complex like RbI3 or Ki3, and this is actually the reactions where the Ki is react with the iodine and Ki3 is going to form, and this is Rbi is going to react with the iodine, and Rbi3 is just as a product which we here see. Next, so there are a large number of the complex ion formation in this liquid SO2. Okay, and solubility of this iodine, we already here discussed, is increases, and as we goes on addition of this potassium or rubidium iodide, and that is the reason the formation of these two complexes, that is Ki3 and Rbi3. Now let's see advantages of this liquid SO2 as a solvent. In that, most important advantage is low boiling point. Okay, and basically this low boiling point is allow its easier evaporations. Okay, now next is low melting point, and this low melting point is allows the reaction at the low temperature. Okay, so there are a number of interesting reactions and valuable reactions which is performing below the in a very moderate temperature, okay, in a very lower temperatures, and that's why it's also useful. Next is inert solvent. It is actually overall inert solvent, so it doesn't affected by any surrounding chemicals which come in contact and proceed the reaction smoothly, okay, without affecting itself. Next important one, better solvating power. So liquid SO2 has unusual solvating power for the both covalent and ionic compounds. Then last one, it is used as a diluent for superacids. It is used as a diluent for the superacid, and in that superacid HSO3F SbF3, it is actually the superacids which is help in reducing its viscosity without affecting its acidity. Okay, so this is the factor, and this is the number of this is actually the advantages of this liquid SO2 as a solvent in number of ways. So with this, students, we are finishing this unit here. For that, we go through this references books, where the Exchange publication is also a very good book in the inorganic chemistry. So there are the volume 1, 2, 3, 4, and through this volume you can understand the given topic in a different point of view, and in a different ways. Through that you can understand. Okay, so there are also some other books is also given here. Okay, so study well, and if any doubts and any related study related issues, please discuss with me. Thank you very much.